All right, let's go. So with last week's work, we talked about functions. We talked about domain, range, set notations. So those are the things I wanted you to focus on. And if you had a practice of these questions, you would have got these answers. These are your answers for your notations. But what I want to move on today is I mentioned you got the second part, and I've got these set of questions here because we are running out of time. Starting from next week, we want to do revision. The problem is there's a lot of interruptions. You've got your curriculum day and whatnot, and we might lose a couple of sessions, which is not ideal for us. Okay, so I've got the questions. If you want to work ahead, you can. The stuff I'm going to talk about is very conceptual. So that means that a lot of it is transferable to multiple exercises. Okay? And today I'm going to try to talk about the ideas to try to take in the concepts, and that's why I'm recording it. That way you can also look back and just try to remember what I was saying. Okay? All right, so first things first, we've got to understand what is a function. A function, which I'm just going to check the color, it's red. Okay. A function, I want you to think of it as, it starts off with what a relation is. Okay, you got to know what a relation is before you know what a function is. And a relation, another way to remember it is it's a set or group of coordinates. Very simple. If you've got a bunch of coordinates, it's called a relation. So an example would be something like if I had 1, 1, 2, 2, I don't know, 3, negative 100. That's a bunch of coordinates. I just gave you 3 coordinates. That, as a group, is called a relation. Whether it looks like something or not, we don't know. Okay, we just know it's called a relation when you have a collection of coordinates. Now, these are all coordinates that may give you a graph, may not give you a graph. I have no idea. But I know when you have a collection of coordinates, it is called a relation. Now, a function, the way I like to think about it is for every x value you put into this function, or think of it as a machine. Okay, so think of this function as a machine. If this is a machine, then whatever you put in, this machine is going to alter it. And when I say alter it, this machine could be x squared. So that means whatever number you put in, you're going to square it. If you said 2x, that means whatever number you put in, you're going to double it. Okay, so this machine will alter whatever the x value is, and it spits out a y value. Okay, so you put in an x value, we call the input, or we call the pre-image. This is called the pre-image. So you put something before the image, and then it shoots out or spits out an image after the machine has altered it. So we call that the image. Okay, so you've got a pre-image, you've got a machine, which is your function, and it spits out an image. So you're like, sir, so how does that relate to a relation? So a function is a relation, but in specific, it only spits out one y value. Okay, so it only spits out one y value. So you think about it, if all the functions you've had, whether it's quadratic or linear or a square root function, every time you put an x value, there is always just one y value. You've never had repeated y values. And I'm going to draw some pictures later so you can see when it's repeated, and that's not called a function. Okay, and why your square root function is only the top half rather than actually both top and bottom. Why is your circle split up into semicircles, and you have to type it in your calculator, you have to type 2. The reason why you have to type 2 is because it's called a function only if you have one y value. Whereas if you draw a circle, I'll show it to you later, you'll see that it is not spitting out one y value, but it spits out 2. That's why you can't draw on your calculator 2 circles. Okay. Now, keep that in mind. This means, I think I'll rub this off. This means a function is a relation specifically when there is only one unique y value or y coordinate. And so, let's take an example. If we have a look at this, I've got a bunch of coordinates. And how do you know just by looking at coordinates whether you have a unique or you have a function? Is that if you look at all your x values, as soon as you have a repeated x value, okay, that means that this has 2 y values for the one x value. So that means if I put an x value of 1, I'm getting out a -2 I'm getting a 3. This is not a function. Okay, so you can see here with -1, if this was my machine, I put in x equals 1, it tells me I'm spitting out a -2 or I'm spitting out a 3. That is not a function. So our function says that if you put in 1x value, you're going to get 1y value. You can put 2x values, doesn't matter how many x values you put in, but as long as you get 1y value out, it's called a function. Okay? And so what's an example of not a function? It would be something like if I put in, what is a function? So for example, a quadratic. So if you think about a quadratic, if this machine was an x squared, and I put in x equals 2, you'd say the y value would be 4. But even if I put another x value in, -2, the y value is still 4. There is no point at one point where I do not have a repeated x value. If I put 2, I'm only going to get 4. I'm not going to get any more. This is why your square root function, you see your square root function is an issue here. When you put in x equals to 4, technically root of 4, you've learnt that there is y equals to +2 or y equals to -2. That is not a function. That's why in your equation, when you write square root of x, you don't sketch both top and bottom, because this is no longer a function. This is a function, so that's quadratic. You put in 1x value or 2x value, you still get the 1y. But when you look at a square root function, which is the inverse of a square, the square root function, when you put in a 4, you have to choose. See, the top half would give you +2. The bottom half gives you the -2. That's why we split it up. And that's why we call it a square root function. Otherwise, it's called a square root relation. Okay, so if I draw it visually for you to see, so when you do this, square root of 4, so when x is 4, y has a choice of being 2, or it has a choice of being -2. This is actually the graph of a square root relation. But because when we're talking about functions, it wouldn't be a function if you had 2 different y values for the one x value. So when I put in a 4, I get 2 y values. That's not a function. That's why when you graph a square root function, it only graphs top half, and the negative makes it a reflection. Okay. Whereas a quadratic, on the other hand, a quadratic is fine. It's technically the same shape. It's just going up. So this is pointing up. This is pointing on the side. It's still the same thing. You're pointing up, but this is okay to have both sides because you still only have one y value, even though you have multiple x values. Does that make sense? Yeah. So this is called a function because you only have one y. There's only one y. Where over here, for the one x, you get 2 y coordinates for the 1 point. Yeah. And that is when it's not a function. So if you think about it pictorially, put a 4, if you get 2 values, 2 y values, then it is not. And then how do you tell from the coordinates when there's a repeated x value? Okay, so when there's a repeated x value, you know it's not a function by definition. Okay, so by definition we're saying a function is a bunch of coordinates, and in those coordinates specifically you do not have multiple y values. Okay, you can have repeated y values. Okay, you can have repeated y values. For example, this would have been 2, 4, -2, 4. Okay, so you can have repeated y values, but you cannot have repeated x values because that implies that you're going to have 2. That means for the 1x you get 2 y values. Okay, or more than 2. Okay. All right, so that's what a function is. Now, that also means that when we take this apart, it also means that when we do our functions, these are one of the things we have to look at. And remember I taught you about domain and range. That means your domain has to make sure that you're always going to get a 1-to-1, or for 1x you're always going to get 1 y value. That's the aim, and that's the hardest part that you have to understand. If you understood what a function is, that's your goal. And that'll be a year 12 content in the sense that you have to restrict a domain such that it works, so that you do have So that for every x, you get one y value. That's the aim. Okay. Now what I'm doing here, this is called a function notation. And this is jumping to exercise 5F right there. Okay, this is called function notation. And if you noticed at the start of the year, I've been trying to teach you how to use f of x. I said move away from using y equals to x squared. We're now using f of x. And the reason why is you're going to have to get used to this notation here. Okay, so I'm going to describe this notation for you, just in another color so you can see. F colon just means what letter are you using to describe this machine. Okay, so this is my machine. I happen to call it F. Okay, it could have been G, could have been H, could have been T, whatever it is. But whatever you call it, if it's F of X, then you use F. If it's G, you use G. If it's G with a negative power, then you put G with a negative power. Okay, so this tells you what letter you're using. This tells you the domain. So for all the x values, so right here, that tells you the x values. So the domain, you can only choose between numbers from 1 to 4. Okay? So I gave examples here. I said group set at bay. My domain is 1, 2, 3, 4. Could have been more. Could have been 1.1, 1.2, but I'm just choosing 1, 2, 3, and 4. Okay? This arrow means maps onto. So I'm going to write here, whoops. This means maps onto. And for a lot of us at this point, you're not going to have to understand this up until you learn different type of number systems. Right now, what this means is your domain will be a part of your real numbers. So they're just saying all your answers that you can potentially get can be mapped onto this picture, this Cartesian plane filled with real numbers. Because sometimes you can just be mapped onto just integers, or it can be mapped onto imaginary numbers. Okay. For our sake in methods, we only ever deal with R. So you always see, if you look back at your textbooks, that will always be maps onto R. Okay, so you don't have to worry about it. It means when you write it, it's always going to be arrow R. Okay, so you're always going to have maps onto the real number system on real numbers. The name for this R is called the codomain. And I'm going to try to explain what the codomain is in the next slide so you can see what I'm trying to say. Okay? And then finally, they tell you the machine. So I have to have a comma. There's a comma after you map onto R, comma. F of X is your machine. So notice that I'm using X there. The reason why it's X is because you're telling the person who's looking at it is you're saying, okay, I'm calling it F. And within F, I have the letters X. Because it could have been F of T. F of T means that within the function F, I'm using the letters T. Okay, and it's important when you type in your calculator, if you use F of T, then in your equation there should be T's. If you wrote F of X, then in your equation it has to have X. Okay, then it only deals with X. That's what we're saying there. Okay, so we're saying in this machine, I'm dealing with X values. So F is the machine, the Y values, is responsible based on what X does. Okay, so if you think about the pre-image and the image, the pre-image is F. The pre-image is X, and the image is F. Okay, so this is my machine. I'm going to write here machine. My machine is, I'm going to square all the numbers. F is my Y values, and X is my X values. Okay, and an example would be here. So I'm saying if X was equal to 1, then F of 1 gives you 1, because the machine says 1 squared. So 1 squared is 1. You can say if X equals 2, then F of 2, which is 2 squared, gives you 4. Okay, if I follow this onwards, what I want you to see is these are all my range values. So you would call this your domain. This is your domain. You would call this your range. Okay, but what you should notice is because my domain is only from 1 to 4, that means my actual range is only from 1 to 16. So what about 25, 36, 49, 64? Because technically, this machine can do that. But it's just the numbers that I've selected. I've only selected from 1 to 4. So we call this your codomain, which is what kind of numbers would you have? And we call it your real numbers. Your real numbers are all the numbers that you could potentially have. Could have been 5 squared, could have been 5.5 squared, and that covers every number that you can think of. And therefore, That's called your code domain. So your code domain is part of that range. The range is coming from that code domain. Okay, and for our sake, it will always be real numbers. Just to remind you again, well, if you learned psychology, then we call this your independent variables and dependent variables. Reason why is because 1, 2, 3, 4 was always by itself. It never had any alterations to it. Dependent variable means you can't get 4 unless you had 1 or 2. Okay, you can't get a 4 unless you had the 2. You couldn't have gotten any of these numbers unless you had these first values. That's why we call this the pre-image. The image cannot occur unless you had the pre-image. Okay, so this is dependent variable because it depends on what you have and what you're putting in. Okay, so we call it dependent variables, or you can call it the pre-image and the image. So you can't have an image unless you have your pre-image. Whatever you're putting into the machine, before you put into the machine, then you get something out. But if you don't put anything in, then you don't get anything out. That's why this is called dependent. Okay? What I've just shown you just now, or just described to you, is pretty much 5C and 5F. Okay, it's asking you to use function notation. What I've just done implicitly here for you is using function notation to describe when x is 1, y is 4. Okay, that's one, then y is 1. Okay, so instead of saying x is 1, 1, you can now write f of 1 equals 1. That means the same thing. Okay, so it's just saying y value is 1, y value equals to 1, and x is currently 1. Okay, that's what I'm trying to teach you here. Yeah. Now, this is my interpretation of the code domain. If you still didn't understand that, I thought, let's do another interpretation. Let's say a favorite ice cream machine. Okay? Let's say that's your ice cream machine. You put Captain America in, you get lemonade. Okay? So, lemonade flavor. If you put Wolverine in, you get banana. Okay? And if you put the Hulk in, you get lime. Right? But if we think about pre-image and then the after image, well, pre-image is what I'm putting in. So obviously my domain or independent variable would be the 3 superheroes that I've chosen. Yeah? And the flavors that come out is called my image, range, or the picture of the dependent variable. So I can't get these flavors unless I put these heroes in. Okay? So that means if I were to think about all the flavors that are possible, I technically haven't chosen all the flavors in the world. There's still chocolate, strawberry, vanilla, cookies and cream, mint, and etc. Right? But this is still valid. I still have ice cream flavors. This is not the only ice cream flavors I have. So this is my range. My range is lemonade, banana, and lime. My code domain is this. This is everything that I can potentially have for flavored ice cream. This is what I've chosen. They're independent. See, all these depend on the fact of which heroes I put in to get a certain flavor. Okay. Yes?
Does the code domain include the range?
Yes. Yeah. Because the range is technically the code domain. Yeah. It's just the restricted part of the code domain. And so, therefore, if I were to write it in function notation, you'd say, I'm going to use the letter F to describe this machine, this ice cream machine. My domain, which is the heroes I've chosen, I've only chosen Captain America, Wolverine, and Hulk. That maps on to, technically it's R, okay, but technically it should just be all the ice cream flavors that you can think of, okay? And then whatever I'm putting in, this is my machine, F of the hero that I put in, so that's my Y value will equal to the ice cream flavor. And that is my way of interpreting, function notations. It's what you're putting in and what you're getting out. That's what you're getting out. This is the machine, I'm putting a hero in, these are the heroes I've chosen, and what are my results coming out from? Okay, my results are coming from all the flavors that you can think of for ice cream. Easy? Okay, so now that we know what we know, okay, this is just me trying to describe to you. G of 2 means that when x is 2, you have 2 minus 1, therefore it's equal to 1. So what that is saying is when x is 2, y is 1. Okay, it's just another way. So you're reading the notation. Okay, remember chapter 5 is all about language and notation here. Okay, now let's do a quick practice here. I'm just going to get you to quickly look at 3A, B, C, and D. Can you tell me which ones are definitely related? So what are you looking for? What's the first thing you're going to be looking for? Karia? Multiple x values. So I'm going to look at the first one. I'm going to say, all right, so I've got -1, bam. The first one has to be a relation because there's repeated x values, right? So I'm going to circle it here again. -1, repeated x values. Therefore, not a function. In case you're confused why, again, think about the machine. That means when I put in a -1, I'm getting two different values. I'm getting y equals 1 or I'm getting y equals 2. See, that's a 2 and that's a 1. And remember a function, we said it only spits out one y value. Okay, so let's look at another one. B. It's got -2, -1, 0, 1, 2. Good. This is fine. Okay, you can have repeated y values. It doesn't matter. This one's fine. So that means part B is a function. This is a relation. This implies that for every x value you put in, you're always going to spit out a unique or individual y value. If I look at C, quickly look at C, I'm going -1, -1 again. That's a relation because if I put a -1 in, I'm spitting out a 1 and I'm spitting out a 2. Okay, and I don't want to have two y values, I only want one. That's what the definition of a function is. Yeah? And then the last one, if we have a look, -1, 0, 1, 2, 3. Fantastic, it's a function. Okay, so D is a function and this is a relation. Based on that idea that a machine, you sub in, you can put as many x values you want in, but it only has to spit out one y. That is the definition of a function. Cool? Okay, and that will be carried on to next year's chapter 1, and you'll be spending your time, like 2 weeks, to recover that idea again. It's a very simple concept, and it's hard to do just because you have to now look at graphs and find when you will have one y value. So when I draw the machine, it makes it easy, but when you start drawing the graphs, it gets a bit tricky. Okay, so that's why what I'm going to do, don't worry about this, types of relations. Now I mentioned before that there are relations and then there are functions. Now you think about the functions you've learned. You learned linear, you learned quadratics, which is a parabola, quadratic function, you learned square roots. Each one of those, and circle functions or semicircle functions, each one of those are different types of relations or different types of functions. These are your 4 types. I'm going to draw the machine there just so you can remember again. These are your 4 types. You've got a one-to-one, one-to-many, many-to-one, and many-to-many. Okay? And the one way I normally remember this, it means that if you put one x value, you get one y value. If you put in one x value and you get many y values, so this is more than one y value, okay, which is, we know, is called a relation. Remember I said you only want one y value for it to be a function. So this is called a relation. A one-to-many is a relation. A many-to-one implies that you can put many x's, many x values, and you get one y value. And obviously with the last one, you put in many x, and you get many y's. So out of these 4, which ones are called a function? Which ones are a function?
One-to-one and many-to-one.
Yeah, one-to-one and many-to-one. As long as you have one y value, this is what you wanted. And it's the basic, most key concept for the very first part of your multiple choice next year. I promise you it's going to have this type of question. They're just going to test if you know what a one-to-one is. And the one-to-one implies if you understand what an inverse function is, which I'll talk about in the next session. But this is the first step. So you understand what a function is, and you can remember all 4 because it makes sense. One-to-one just means if you put an x value, one x value, you get one y value. And that's your linear equation. If you think about linear, that's a one-to-one. Because if you put in, let's say, if the equation was y equals 2x, if you put in 2, you get 4. So 1x, or you think about the machine, you put in a 2, you get a 4. Yeah? That's called a one-to-one. So this is one-to-one. That makes sense. Let's look at a one-to-many. That is your square root function. You see, if I put in one x value, root of 4, so if the machine is y equals root of x, root of 4 gives me 2 potential answers. It is a positive 2 or negative 2. This is called a one-to-many, because I put in one x value and I get 2 y values. So if you think about the machine again, you put in a 4 and you get 2 or -2. That's why that's not a function, but it's called a relation. If you think about a many-to-one, what is a many-to-one function? The one that you've learnt is a quadratic. That's a many-to-one because I can put in 2 squared, y equals x squared, gives you 4. So for 1x, I get 4, but not only that, at -2, I also have, so -2, I also have 4, and at 2, I also have 4. So visually, you can think of it as you put in 2 or -2, and you get y equals 4. So that's many x's, and you get one y value. So that's why we call it a many-to-one, and that's a function. So anything that spits out one y value is called a function. That's a function, that's a function. One-to-one, many-to-one. And then you got your last part, a many-to-many. Well, the many-to-many only has a circle. Circle's the only one where you have repeated x and you have repeated y values. And so this is a many-to-many. Is this starting to consolidate what a function is? Yeah, think of the machine. If it helps you think of the machine, these are your 4 types. You don't have to memorize them because you get your different scenarios of your different graphs. Okay? Now, if you get that, the vertical line test, there's a vertical line test and a horizontal line test to decipher which one is a one-to-one or whether it's a function or not. Now, I don't want you to memorize this. You see, I want you to think about it logically. If I use a vertical line test, which means if I drew a vertical line down, 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 what I want you to see is logically, this will intersect this once. This will intersect this once. This would intersect this twice. 1, 2, 1, 2. Now what do you notice about these two sets of functions? One-to-one and a many-to-one. What's so special about these two? Yeah, they only have one intercept. But what type of relation is this? Those are functions. So when you do a vertical line test, if it crosses once, logically, yeah, it means that you only have one y value. Whereas if you cross twice, it implies that you have 2 y values. If you have 2 y values, it's called a relation. So the vertical line test is just checking if you have a function or not. That's all it's doing. So you don't have to memorize that, because a lot of times I ask my students in year 12 and I say, which test do we use to find out if it's a function? And they're like, it's like a 50-50 game. But it's like, why? Why is it a 50-50 game? All you have to do is think about it logically. Well, if it cuts it twice, what does that imply? You've got 2 y values. Well, 2 y values means that you don't have a function. So therefore, a vertical line test is whether you have a function or not. Okay? So that's a vertical line test. A vertical line test is just used to determine if a graph is a relation or a function. So for example, each one of these, which one is a function? Just by looking at it, using a vertical line test, which ones are functions? Go A, B, C, D, E, F. Which ones are? Yeah. How easy was that? Because in my head, I can do a vertical line test, and you can see anytime it crosses twice, it means I've got 2 y values for the 1x value. And therefore, these 2 aren't functions, but the rest are. This is a function, that's a function, this is a function, that's a function. Easy? So then the next question is then, well, what's the horizontal line test for then? Okay? The horizontal line test, well, let's go back to this again. Whoops. If I go back to this, I'm going to use green now so you can see. If I did a horizontal line test, so let's do crosses once, crosses once, crosses twice, crosses twice. Whoops. What do you think a many-to-one, what does a horizontal line test do? What's the pattern? So this one crosses once, this one crosses once, this one crosses many, crosses many. What's the pattern about these two? What's the pattern? So one's a function, one's a relation, true. So obviously it's not testing if it's a function or a relation. What is it testing? Yes, Atish? Yeah, it's just whether it's just testing if you have many x values. Okay, so this is a many-to-one, this is a many-to-many. So this horizontal line test just tests whether it is a many to something or is it a one to something. And the reason why you need that is for the next exercise for an inverse function. Inverse functions only work if you have a one-to-one. So you do a horizontal line test to see if it's a one-to-one or not. But that's for the next exercise. Okay? So I want to stop here at the horizontal line test because that technically I've just covered 5B to 5D. Okay? And these are the questions I'm going to get you to practice. But if you really understood what I took out, I just taught you what is a function, the 4 types of functions, what a vertical line test is for, what a horizontal line test is for. That's the aim. Okay, now the domain and whatnot, I'll talk about in the next session. Okay, and get you to practice some questions as well. Okay, I'm going to hand these questions out. Please have a look at, I don't want you to do, or I'll try to really select it minimally so that we can progress faster. Okay, the aim is to understand the concept. Don't do too many. Try to understand it rather than just do it laboriously doing a lot. Okay, so I've tried to reduce the number of homework, but I'm going to pass this out, and I've already posted this PowerPoint up onto Schoology, and I'm going to post this video up onto Schoology as well, just for you to watch if you missed out on anything or if you've forgotten something. Okay, and I'm going to export this as a PDF so you can see the notes if you want to look at the notes again as well. Okay. All right, I'm going to pass this out. Want to pass it on?